issued from 1969. In 1970, we added aeration. If you look at the Google Earth, you'll see these splash aerators. They were added in 1970. Margaret Street Pump Station, serving Alberni, was added in 1963. Argyle Street Pump Station in Southport in 1971, but completely replaced in 2008, 39 years. And the Josephine Pump Station in 1977. And it's worked well for us. In 1997 and 2004, we removed the biosolids. That's a very similar process that we just conducted, removing the sludge from the Catalyst Lagoon. It's a suction dredge that we removed, and those projects were, I believe, 1 million and 600,000 respectively in 1997 and 2004. And most recently, it's the frequent notifications from the Ministry of Environment that has put us on the liquid waste management planning process. I've talked about it a number of times. It's a process that we walk through with the ministry. We develop a stage 1 plan, a stage 2 plan, and a stage 3. Tom will speak more specifically about that. But it has taken a while to walk through that liquid waste management planning process with the ministry, and it's been ongoing. But the ministry has been supportive of us, knowing that we are in this process of a liquid waste management plan, and in fact, you'll hear later that we did get awarded a sizable grant. So at this point, you know, a little bit of history there. I'd like to introduce Tom Robinson from Associated Engineering to take us through more of the liquid waste management planning process and specifically where we are today. Thanks, Tom.
Okay. Is this as straightforward as, oh, here we go. You're setting me up. Do I need this?
Yes.
For more than a pointer?
You can click back.
Okay, excellent, thank you. I apologize for looking like I'm on vacation. It's because I am. You know, you try not to take work home with you, but if you can bring your family to where you go to work, it's probably an indication that you're enjoying your work and that you're having some fun. So it's great to be here today. So again, just picking up where Guy left off, I want to take you through just a brief outline for the topics that I want to cover with you. We're going to talk about the regulations that are in place now that weren't in place in 1958 and in 1969 when Guy was giving you the history. We're going to talk about the second bullet there, which is called the liquid waste management planning process. And we're going to talk about some of the environmental impact work that we've done in determining the direction that this project ought to take. We'll lay out some of the key project elements for how we're going to meet those requirements, talk about the costs, and then take your questions. So 2012 was a significant year. There was a new federal regulation put into place in an area where there had been nothing before. This was a gap that the federal government felt that was needed to fill because across the country there was a very patchwork approach to municipal wastewater treatment. Not everybody was meeting the minimum standards, and they felt that they needed to establish some minimum standards, and this is called the Wastewater Systems Effluent Regulation, or WESR. It establishes, as I said, national standards, and it specified the timing for compliance. Bit of a story here, I won't go into it. It doesn't all apply to you, but for jurisdictions that had longer to go, suffice it to say, if they applied for a process and were granted that approval, they were given more time to get there. In Port Alberni's case, they did not meet that criteria, so you're responsible, according to this legislation, to be compliant by 2020. The province revised a regulation that had been in place for a number of years and revised that in 2012. This is the more significant of the regulations that apply to you, and more significant because it outlines the key areas where your present system does not comply with the regulations, and there are many of them. Your daily flows vastly exceed your permitted value. As Guy had indicated earlier, some of those flow numbers were established many, many years ago. So you're now greatly in exceedance there. The discharge system has to be an engineered system that provides dilution, and there are protocols for establishing what that dilution should be. Your present discharge from the city lagoons is basically a ditch that discharges into the side of the Somas River. So not meeting that criteria. Your system must have redundancy. By redundancy, what we mean is that you can take a portion of your system offline to do maintenance and still have the system can carry on and be functional during the time that you do that. Your present lagoon is a single cell lagoon. There's no way to take any of it offline. Secondary treatment effluent limits. I'll show you a slide indicating that those have been tightened and that you're frequently not meeting the new limits. There are criteria for protection of human health involving disinfection of final effluent, which you're not providing. And there are some cumbersome, or I would say particularly challenging for Port Alberni, requirements on where you can actually locate your discharge. I'll get into that a little bit later. So it's always nice to have a bit of a visual. You can see on the left-hand side, in 1979, the treated effluent limits were 70. Guy, you said 75 earlier, but anyways. 70, okay. 70 milligrams of liter for both BOD and TSS. I'm not going to assume that you want to be experts at the end of this short presentation, but BOD stands for, it's an acronym which stands for biological oxygen demand. It's a measure of the organic pollution still in the wastewater that then has to be dealt with by the environment that you're discharging into. And TSS is a little less abstract. It's suspended materials that if you were to pass the water through a filter, that would be retained on the filter. So back in '69, 70 was the number that was allowable for either. And you could see in the new provincial and federal regulations, the numbers are 25 and 45. Why are they different? The federal government proposes to measure it differently than the province does. For all intents and purposes, I will hereby refer to that as a secondary treatment requirement. So if you have a properly functioning secondary treatment system, you would meet the new regulations. So, in recognition that there is work to be done and money to be spent, the province has an alternative to the municipal wastewater regulation for providing an alternative method to reach compliance, and it's called the liquid waste management planning process. It's important to understand that the end point is the same as the municipal wastewater regulation, but this process provides some flexibility when it comes to implementation. But it has other requirements as well. It has the requirement that you work with your community, stakeholders, First Nations, and the public on a plan that everybody can agree to. And this is, in fact, where we have been spending a lot of the time and the effort up until this point. And it's also, I would say, where we have achieved some significant benefits for the project. There are 3 stages to the process. I'm not sure how relevant they are for today's discussion. We are in stage 2, and I would say approaching the end of stage 2, which means that we are in a point where we can select and seek endorsement of the preferred strategy. Stage 3 is really just a formalizing of that strategy, so it's a less significant stage. So one of the interesting things for the city is your commitment, going back to 2004, to work with the SOMAS Estuary Management Plan. And for those that don't remember, this was a plan that was developed and endorsed by the city, DFO, SISHAT, Upachessit, Ministry of Environment, and other stakeholders. The graphic there shows the area in question. And you may notice, is this a pointer as well? It is? In the middle, maybe? Ah, in the middle, right there. Sorry, I'll show it on a couple. That's the lagoon that we're talking about. You will notice how centrally located that is in the SOMAS estuary. So the vision was to maintain and enhance the productivity and diversity of the natural resources in the estuary, with consideration for social and economic returns and benefits to the community. And specifically, Objective 7, work with others on management of discharges to continue to improve the water quality in the estuary. So these are significant commitments that were made that have helped us moving forward. The good news is that back in 2011, on an initiative that Guy Sisson and Ken advanced at that time, the city received $11.2 million in grants from the gas tax program for upgrades. It initially came with a deadline of 2016, but that's been extended to help with the time that's required for the liquid waste management planning. This was a significant grant, and one that was very happily received at a time when a lot of other local governments were kind of wondering how you pulled that off. So just a little bit of a project history from 2012 to where we're at. There'll be a matching slide that at the end that shows where we're going in the future. So it starts with I didn't go back to 1958. Starts with 2012 with the award of the gas tax grant and the acquisition of the Catalyst Lagoon in 2012. I've talked a little bit about the liquid waste management planning process, which was initiated in 2013 and is still actively moving ahead as we speak. We've had a total of 7 meetings. We have also met numerous times with the SISHAT. Because this project is in their traditional territories, and because a lot of the objectives that we talk about are shared objectives with them, and this is a very important relationship for the city. We've also met numerous times with the Upachessit, even though the diagram doesn't show that. We've done not a lot of environmental monitoring and modeling, but we've done what the process requires and what adds the most value to the process. This past springtime, after a few years of trying, we successfully had an archaeological investigation of what will be the outfall pipe routing, and we're waiting for the report from that. And for those that may be already aware, we have undertaken a dredging program of the Catalyst Lagoon to remove the solids that were deposited there by catalyst operations and move those into a catalyst landfill before the city starts their own operations. Let's take a pause if any of you have any questions, because we're sort of moving in to the meat of a few things. It's a bit of a natural break.
How's that dredging project proceeding?
It's proceeding well. We are in a little bit of a hiatus between part 1 and part 2. They're bringing a new piece of equipment from the east that will harvest the bulrushes a lot more efficiently than the original equipment that they've brought. So that will start up again, I think, July 24th, run for another 2 weeks or so.
And was it being deposited at Block 105, or was it?
Yes.
And it going through town and through the APD property, no problem?
Yeah, we worked with the Sichat to establish a route that would get through their territories with minimal impact. That was during the month of June. There was still school buses and that kind of thing moving around, so it was important for them that that be handled properly. But otherwise, yeah, it's been very smooth since we've been doing that.
Okay, thank you.
Another question?
Yeah, interesting. I've kind of been watching this going on for a while. I appreciated the tour head out of there with Ken Watson and Tim a while back, and it looked to me like things are finally actually happening in a person like me who doesn't really understand everything that's going on out there. I got that part figured. Just curious, we got 11.2 million way back in 2011, which wasn't all that long ago compared to the length of time this project's been looked at. How much of that we got left?
I'd like, cost estimates are on the, a part of my presentation, but also something that Guy and Ken will be handling later. I think it would be better for your question.
I can wait that long, yeah.
Okay. So what did the Wastewater Advisory Committee, the committee that has been working with us on the liquid waste management planning process, what have they told us? They have told us that the most important thing to them is to protect salmon from any adverse effects arising from the discharge. That might sound like a fairly straightforward thing, but actually this is, it took some time for the issues to become sort of sorted and prioritized in people's minds. And considering all things, including the regulations, it's really the value of the fishery in that in the estuary that rose to the top over a period of many meetings and with stakeholders and input and so on. So the priority to improve the quality of the environment in the Somas estuary, and after all, that shouldn't be a surprise. That's consistent with the agreement that you entered into in 2004. There is habitat that can be restored to reduce the footprint out in the estuary. Most for the most part, that would refer to the city's existing lagoon, which will be a surplus facility at that point, and is something that could be returned to the natural environment. That's been quite an enthusiastic attribute. And lastly, of course, protection of human health. One of the things that the municipal wastewater regulation, one of the driving forces in its development has actually not been for the protection of fish specifically, and has been for the protection of human health. And that has created a very curious challenge for the Port Alberni project because it requires that a discharge into an estuary be at a depth greater than 10 meters at all times. So for Port Alberni, that means we have to look at a low tide and go down 10 meters from that and make sure that the discharge is taking place below that depth. The reason that the regulation was developed that way was definitely not with Port Alberni in mind. It was developed that way in order to establish a low likelihood that people that are recreating on the surface of the water would ever become in contact with that discharge, because as a discharge enters the environment, it normally rises and starts to mix, at which time it gets trapped and stays below the surface. So that was considered sort of the final measure of safety that the regulators could incorporate. But in Port Alberni, the problem with that is that puts the discharge well into the salt water, below the fresh water. The divide between the two is called the halocline, and from a migrating salmon perspective, this is about the worst place they wanted to see that go. And so we've been stuck between the objectives for fish and the regulation that doesn't have flexibility, or very much flexibility at all, in that area. So this is a theme that's been a part of the discussions now for almost 2 years, and it's had a fairly significant impact on the outfall. But to give the regulations their due, what they are wanting to do is protect human health, and we can do that now with ultraviolet light, which will greatly affect the ability for pathogenic bacteria that could still be present to be active and representing a significant risk when they're released into the environment. So if you're a recreator or a fisherman, like these two gentlemen in the photo, this is a good and necessary measure to be taking. I just wanted to give you some idea of the various locations that we looked at. I don't want you to feel as though we haven't worked very hard to find the best location where we could be putting a discharge. It's been a while since we've concluded these discussions. But number one on the figure there represents discharging into the river. This was looked at because initially we thought the location could be, the discharge pipeline would be shorter and cost less money. In reality, it draws in another couple of regulations which are very problematic and pretty much rules that out. 2A, which is a location which would have been, actually that's where we're ending up, is 2A, so I won't say too much more about that at this point. 2B, believe it or not, is where you would be if you had to comply with the 10-meter depth requirement. It's a long way out there, at considerable expense in getting there. The item number 3 was looked at briefly when we were interested in exploring whether adding treated wastewater into the estuary environment could actually be a benefit for that environment. But that was ruled out because the substantial addition of fresh water in that environment would significantly change the saltwater marsh that is presently there. There would be species change. There would be quite a few impacts that were not intended. So that's just a few of the locations that were looked at. Oh, forgot I had. Yeah. Okay, well, there you go. So I indicated earlier that we've had to investigate the environment. Not a big surprise. There has been an impact on the environment of your present discharge. We've heard about this in our discussions with the CSHAT when they have talked about setting their nets and pulling in their nets, and if they've been dragging at all on the west bank of the river, they talk quite a lot about a very black, sticky mass that they have to clean off their nets. And if you're in the business, you kind of know what that is, and that's the result of biological activity on the bottom becoming anaerobic because the oxygen demand is higher than the natural systems can meet. So things turn black instead of green, and so part of that was quantifying the existing. But more particularly was involved in scoping the second stage, where we would be looking at the pre-discharge environment for the new system that we're looking to put into place, and determining that those impacts would be acceptable impacts. There are sophisticated computerized modeling techniques to predict where discharges end up and how they mix. we were able to, in all of these environmental studies, draw quite heavily on the significant effort that's been done over the years by Catalyst for their discharge in the environment. And it turns out going forward that that's been a significant benefit to the city. But really, if we want to look at the cumulative total impacts of discharges into Alberni Inlet, we need to be looking at those two discharges together. And Catalyst, of course, had spent a lot of money over many, many years looking at this. And they are likely to be your partner going forward as you are looking at those cumulative impacts together. So what does the municipal wastewater regulation require of us? It requires that we determine that the water quality guidelines are met at a distance of 100 meters in any direction from the discharge, and that the treatment levels for bacteria and ammonia are acceptable in that environment, and also that we're not depressing the natural dissolved oxygen in the environment at that time. So we've looked at this, and where that has ended up is, now this is a little bit hard to see, but again, I'm going to show you, that's the former Catalyst Lagoon. That's what we're talking about there. Has a sort of a very characteristic shape that you can easily see on Google Earth or mapping. And the outfall line will come out from there and ultimately discharge at this point. So for you folks over here, we'll discharge at this point here. The present Catalyst discharge is in this environment here. And that comes out on a flume system, and some of you may be familiar with that. So, you know, not a surprise, I suppose, that we're in the same general environment, recognizing the fact that the regulations would have us, you know, considerably further out if we were just following those regulations and not actually going through the environmental impact process and working with stakeholders. Here's the city's current lagoon here, right there.
Where's Fisherman's Harbor in relation to this?
Is that the, help me out here, guys, is that up in this area?
No, it would be just down directly across from the plant.
Okay, at the foot of Argyle there. Okay, so I'm going to say it's down in this area.
Below the end of, I think it's off the ditch.
Okay. Yeah. Okay.
Dennis?
Just one question. As the results of your projected planning of where the discharge is going to be, is that kept in calculation with Catalyst discharge?
I'm sorry, I didn't understand the question.
Yeah, I'm just wondering, because the discharge being 100 meters and all that, I understand that. But is there going to be an effect because we're in a general area also of the Catalyst discharge?
I'm going to actually turn that upside down. When I said it's not a surprise we've ended up in the same general area, I think it's because that is the location and the method for minimizing the impact. So Catalyst worked for years to find out how they would minimize their impact. They actually discharge onto the surface. Of course, they don't have a discharge that has any possibility for pathogens, so the whole human health disinfection thing was not a part of their consideration. They were looking at how to avoid a deep discharge into the area where the fish are, and to stay near the surface where that stuff would move out, you know, the most effectively out of Alberni Inlet.
But are they not only under the same requirements as we are, as per the ministry?
They are not regulated under the same regulations as you are, no. No. So, you know, under the Federal Fisheries Act, I think, is where the pulp and paper operations are governed. But, you know, obviously these things are trying to achieve, you know, ultimately the same, you know, goals. So they established that location many years ago, and one of the great benefits to the planning process that this project has brought is that we're now able to discharge closer to the surface by working with stakeholders and the ministry. We will be looking at a discharge that is much closer to the surface, similar to where they are and in a fairly similar location.
Yeah, my concern is just the environmental impact for fisheries when we're adding towards the catalyst discharge.
Mm-hmm.
You know, that's my concern.
Mm-hmm, mm-hmm. Yeah, it's. I think key to your question, if I understand it correctly, is the proximity such that we're going to add these two things together. Right?
Exactly.
Right. I hadn't anticipated that question, but all of the work that we've done on the inlet has been with these two discharges in mind, and we are quite satisfied that we're okay there. You know, I would rely on our environmental scientists to give you a better answer. You're just talking to the wastewater engineer and the project manager here, but that's been a consideration now for a long time, so I know we're okay there.
Is there any monitoring of the discharge from catalyst at this point right now?
Yeah. Mm-hmm. Yeah, and I think every 5 years they have to do a fairly significant research effort that shows the effects of their discharge. The good news is that is consistently showing that they are doing better and better over time. I can't tell you when the last 5 years was done, but this is one of the areas where I think collaboration between the city and Catalyst going forward will be mutually beneficial.
Okay, I see 5 years being a long time period, but what do we have set up for our discharge? How many years?
Doesn't work that way, and you are testing me. And
well, it's just the monitoring that I'm concerned about.
Yeah. So 5 years for the industries may seem like a long time, but that was only established after the federal government was assured that they were on the right track. We have not established, to the best of my knowledge, any specific things that we'll be doing at this for your project going forward. What we are doing is establishing the pre-discharge sort of baseline. So what happens is we want to be able to document what was there before we made this change so that we can observe against that and measure against that going forward. So we talked about trapping when the effluent discharge gets trapped. This is what we're finding from the outfall modeling that we've been doing. You can see the predominant flow out of the Somas River moves in this direction. And we would be looking at a discharge in around this area here, I think. So we're confident on the basis of this modeling that we're meeting the objectives, we're meeting the water quality guidelines, and that the fecal bacteria or the potentially I lost my word. Lost my vocab. That happens every now and then. Yes, we'll be at acceptably low numbers there post disinfection to cause a low potential risk for human health.
If I could, are you increasing or artificially increasing, oops, sorry.
Are you artificially increasing or manually increasing the flow rate of the discharge so that it counteracts any inflowing tide or anything like that?
Yeah. Well, that's been one of the so the question. I think I'm going to try and give you your question back in a way that you're intending. Will the flow leaving the lagoons simply flow in an uncontrolled way into the discharge system and into the environment at that point? And if it were doing that, of course, during a flood tide, it would have the tendency to flood back into the river and onto the foreshore. In an ebb tide, it would pool, and in a slack tide, it would pool, and in an ebb tide, it would move out. So Mr. McLemmon may have been asking that question because he's heard that the approach that we're actually proposing would have the ability to not discharge on a flood tide, but would in fact wait until we have an ebb tide and then would discharge at that time, which would be, you know, a pretty significant strategic way to discharge. Not one that we're required to do, but one that's very advantageous to do, and one which the people that are interested in fish and the marine environment out there have indicated that they would be quite enthusiastic about. Now, we haven't actually made that commitment yet, but that's where that discussion's at. Is that?
Yeah, that partly answered it. I'll wait until we get to the
Okay.
end.
Yeah, my concern is, are we able to manually control the discharge because of low tide and such?
That's the system that we're heading towards, yes. The main concern for fish is dissolved oxygen. And this is because of a very environmentally specific situation in the Somas River estuary. There are some years, not all, when the dissolved oxygen at the head of the estuary in the salt water below the fresh water is very low. Low to the point that fish can be threatened as they wait for the conditions to come into the river. So although we've always been able to demonstrate that any potential discharge that's been treated would have a very low impact, the question that's made this very challenging has been, yeah, but would that very low impact be the straw that breaks the camel's back at times? So we've had to work hard at establishing what that impact would be. So we've determined that in between the 4 meter to 6 meter depth, there would be a fairly small zone that would have a decrease of about 0.24 milligrams per liter. So again, for any other, that's barely measurable. So for any other local government in the province that's working on a discharge, they would be able to move very quickly through this, but not so here because of the situation that can exist from time to time. So we've had to take a very conservative approach to that, and look at some of the data that Catalyst has worked with over the years. Below 6 meters, there's negligible change. So this has been a major focus of this, and one that the Alberni, the Somas estuary enhancement groups and stakeholders have been very focused on. There's two pictures there. One of them obviously shows an adult salmon. And what we can say about adult salmon is when they are driven to spawn, they will not avoid heading into water that could have a dissolved oxygen lower than they need. In extreme cases, that can kill them, but more commonly, it just stresses their body systems. But at this point in their life cycle, they're not concerned with that. And so they can actually be quite harmed as they wait for the conditions to spawn. And of course, any stressors on a fish, just increase the likelihood of disease and various other problems. The other question has been asked, however, well, what about the smolts that are making their way out to sea? And the point where we're at in the study right now is we have found some research that shows that smolts are not like adults. When they encounter poor oxygen conditions, they'll out of there. They will move to other areas. They protect themselves more effectively, actually. So this is a very active discussion with the stakeholders whose primary concern is fish, which includes obviously First Nations and the Somas estuary, the various Somas estuary stakeholders.
Is there an an issue with predation because of what you're doing, or is it?
On the young ones?
Yeah.
No, I don't think so. Predation would be, I think, if they were being sort of schooled together, whereas what the research shows is that they're more inclined to move out of a zone to get away from it. So I don't think we're cornering them. The discharge certainly wouldn't be sort of putting them in one place.
Okay, thank you.
So some interesting statements here. There's a low probability of effects on returning adult salmon in most years. The potential for more frequent warm conditions warrants caution and monitoring. We are seeing, more extreme weather events these days. So we would, that's why there is a need for caution and monitoring of the situation going forward. And the last bullet is just the scientific way of saying what I said already, which is for the smolts and juveniles, they tend to move away from unfavorable conditions. I've touched on collaborating with Catalyst. They've been very helpful, very supportive. Attended all of the all of the liquid waste management planning meetings that we've had, and certainly made all of their data available to us, and been very interested in supporting the program. Like I indicated before, the second bullet, they have extensive monitoring that they've done as their obligation under the Fisheries Act. And we expect that you would work with them going forward. It will be to both parties' benefit. Look, I'm an engineer, so I've been dying to get to this part. At the end of the day, we really like the solution that we're bringing for your unique situation, where you're taking a surplus asset that was part of an industrial operation and bringing some low-tech, straightforward modifications to get that to work for you, and yet moving you in the direction of meeting the regulations at the same time. So this thing that's floating in space here shows your existing lagoon here, and your inflows are taking place right here. That's where your various pipes are coming in. Oh, I'm moving my red around. So that's where your present flows come into the lagoon. And as we move to the larger lagoon, it involves bringing those across here to a screening facility here. You don't have screening right now. It's one of the issues with your lagoon. You're not removing any of the plastics and the other garbage that comes down the sewer. So that will be taken out here, and then it will continue down a pipeline that will come this way and discharge right here at this point. And I apologize for the two screens. If somebody's having neck pain, please let me know. What we're doing in this lagoon is we are closing right here to make two cells out of one, because presently you just have one continuous flow through. So on this screen, we're going to close this area here with a new dike and split them into two. So that's to meet the redundancy criteria that I was talking about before, where going forward you can do work on one side while the other side is in operation and still making your permit commitments. There's a little overflow apron here, which in the event of a problem on one side where the level would be building up, it will automatically overflow into the other side, and that would happen in both directions. So that just keeps us all safe from a hydraulic standpoint. Cell 1 on this side, cell 2 on this side, and then down here where we're making some significant change, whereas the present operation from this lagoon overflows a structure here through a 42-inch pipeline under the river to join back to the catalyst side to mix with other flows from Catalyst and go out to their lagoon. We will instead be, we will have 2 pump stations that will control the level of the lagoon. One on this side for this half, and one on this side for this half. This is, these are going to be floating pump stations, and when they're not operating, we're not discharging. So these can be turned on when the conditions are right to turn on, and at the end of summer, when we enter the very sensitive time for fish in the inlet, there's the possibility that we can actually hold the water in the lagoon, and maybe for a period of up to two weeks or slightly longer, avoid a discharge of any kind. So I don't actually know where that's been done before, but that's a pretty significant thing to be able to do to protect the environment and to protect the fish at that time.
Yep. Talking to the mic. If I might ask, I know it's probably not to scale, but how much bigger are the new cells compared to the old one? What kind of capacity difference?
It is to scale, actually.
Okay.
I don't have those numbers in my head, but it is to scale. I'll give you a while to make the area calculations there, and then you can figure it out. I talked about the screening facility. Fairly straightforward building. Not a big thing. Your 6 wastewater lines would come in. It passes through a screen. That would be this thing here, and we can remove whatever garbage is in there down to about 1/4 of an inch. If you've been out at your existing lagoon, don't know how to say it politely, it can be messy. You've got birds and wildlife investigating the things that they do, but it does tend to move things all over the place. And this will prevent that. So your new facility will stay quite clean, and you won't have materials being transported all over the place. The only waste stream from the screening facility is basically, a bin full of very dry material every couple of days that's taken to the landfill.
What's the maintenance cycle for these screens?
How long do they last?
Yeah,
25 years.
25 years?
Yeah.
And stupid question of the day.
No
Is
stupid
there
question.
such a thing as them being clogged or so forth, or they have to be man monitored, or?
Definitely not a stupid question.
Yeah.
Yeah, but modern equipment does a better job of making that less likely. So what we have proposed is a facility that would have space for 2 screens side by side, but we only propose to install one of them, and to see how that goes for a number of years. Personally, I don't think you'll need the second one, but if we're going to build something, it's cost effective to give you the space to do 2 if you want. But if we install a larger unit that can handle your peak flows, I think we'll be fine. So, and in the event that the gods are against you and the thing plugs up and stops running, there wouldn't be a hydraulic problem because the bypass channel would allow things to move around that screen for a short period of time until you're back in business again. So this facility would be monitored and would be reporting onto a monitoring environment the status and how it's operating. So you won't be caught by surprise. In the event that there's something happening out there that needs to be attended to, there'll be alarms. But that would be a very unusual circumstance. I talked about the inlet system. Not all this information is necessarily critical for you, but as the inlet pipe will come down that new center berm that we have talked about, and it'll discharge here. Half of it will go to one side, half of it will go to the other side. This overflow structure here will be dry most of the time. albeit only about 3 inches higher than the level in the lagoon. But in the event that we were to have a pump issue on one side, this would automatically just move the flow to the other side. So lots of detail on here, not necessarily of interest to you folks, but we're using the same graphics in a number of different locations. So aeration in the lagoon is provided with a diffused aeration system. So the figure on the lower left, I'm afraid you have to think of yourself as a diver to understand this. You're looking up, and the line extending here is actually floating on the surface, and it has these drop legs that are fall down to the bottom. They're weighted down at the bottom, albeit floating, not touching the bottom, and these diffusers are imparting fine bubbles into the aeration lagoon, and ultimately the oxygen that's required for biological oxidation of the organic pollutants, which I referred to earlier. So just a 3D rendering to show you what that will look like. Talked about UV disinfection. Many different kinds of it, but here's 2 UV reactors, 3 actually, no 2, that we put in to a wastewater plant in Tawasin First Nation just recently. So closed pipe, and in this section here there's probably 60 or so long lamps that look like fluorescent lamps, and as the flow passes that, the ultraviolet rays actually disrupt the DNA, actually the RNA in the cells, so that they're not actually dead, they just can't replicate anymore. So it's pretty effective. Not a chemical approach. It requires energy, and it's all, you buy these systems with the operation and monitoring systems are a part of the technology. So. And then again, the UV system, which would be inside the building here, you can see the 2 pump stations, one here, that are feeding into the UV system and then ultimately out straight into the outfall. You'll see we have 2 on one side and 1 on the other. I think it's somebody's job to ask me why that could be. But actually, the second one here is a spare pump for either side, because with this overflow, if this pump were to fail, the water's going to overflow this way, and so the second pump on this side can become the spare pump. Be nice to have 2 on either side, but we're trying to be very appropriate with the way that we're putting the system together. The outfall system, this isn't a very sophisticated rendering, but it's going to be a pipe. Ultimately, I showed you where it is. It's going to be buried by a meter or so in the bottom sediments, with 4 ports sticking up through the surface, kind of like that one there. So it'll only stick up by about a meter or so, and the modeling has shown that if we space them, I can't remember what the spacing is here, I think it may be in the order of 100 meters. I might be a little off. So if we take the flow, split it in 4, and discharge it that way, we're able to meet all the criteria. So that's the technical part of the presentation. I suppose you're not going to ask me any technical questions now that I put something else on the screen.
Just one more technical question I have is, anything's been thrown in there about seismic activity or tsunami area? As any preventions have been put into that in the structure of the lagoon here?
Yeah, very good question, actually. You know, the physical location of the lagoon it won't come as a great surprise to you that in the 1964 tsunami that was, of course, inundated. And there's not much we can do about that. That's just simply a fact of life. On the seismic question, though, and this is we're coming into this now. We haven't given this a lot of effort, but it's because we know that there's a few solutions that are available to us. You know, we're building 2 buildings, and of course buildings are vulnerable to seismic. So there has to be some thought and investigation as to what we're going to do there that's the most appropriate. It's almost a certainty that under the lagoon, the sediments that are part of the Somas estuary are what we're going to call liquefiable. So for something that's liquefiable, what that means is that if the conditions are right in a serious seismic event, that actually does liquefy for a period of time. That doesn't mean that everything melts into the ground. What it does mean, in North Cowichan, we recently did an addition to a water station there that involved a second building immediately adjacent to and adjoining an existing building. Well, that building was not, the original building was not designed with any sort of liquefiable thoughts in mind, but the new one was required to be that way. We didn't go back and upgrade the old building, but we did have to allow for the fact that the new building, in the event of an earthquake, could move differently than the old one. So it can settle and it can move laterally, or it can do a combination of the both. And more likely it's the combination of both. So it could move and it could settle, and it could also settle disproportionately. So you could have one part of the building pointing down and so on. So we put it on a raft foundation, which reduces the likelihood it'll want to sink. And all of the hard connections between the facilities in the new building and the old were designed for flexibility. So the piping, actually, we had some special ways that the piping could absorb that kind of movement. And the order of magnitude in that case was about a half a meter. Now, I'm not going to step out and say it's going to be a half a meter or a meter in this case, but we're talking about definable numbers. And I think what we would do in this instance is we would take a page out of a different project where we would design some weakness intentionally into certain areas of the piping system so that in the event that things are moving laterally, it would fail there. But we would put the weakness there because that would be a location where we could repair it in a straightforward manner after a seismic event, you know, hopefully using local materials, local labor without, you know, having to bring things in from far away.
So you were talking about, let's say, the tsunami itself. What would that cause if it was inundated with water? What would that cause for the city? As in to, you know, just, you know, more flooding within a city, within a sewer holes, or?
I think in terms of the tsunami that the city faces, the presence of the lagoon wouldn't change that. What I suspect that it would do would be move everything in the lagoon all over. So there would be, in the vast quantity of water that you're dealing with, there would be a cleanup afterwards, much like there would be if there was no lagoon there. And if it wasn't, you know, I mean, there's a tsunami and a tsunami. There's a whole range of scale there. So what we would be looking for is if they had something similar to 1964. When it's over and done with, we can move things back into position. Maybe those pump stations are no longer in the lagoon. Maybe they're another place. Pick them up, bring them back, plug things together, and get them going as efficiently as you could.
Okay, thank you.
That's kind of how we're looking at it.
Just wonder if you could go back to your previous slide. And early on, you were talking about the different levels, especially
Sure.
the influence on the fish.
Yeah.
And in this depiction, basically, if I'm not wrong, you're doing outfall basically right on the very bottom.
Yes.
So The discussion over whether that should be suspended or at a different level is a moot point now. It's just,
Well, so what we're trying to do is we're trying to find the balance, and not just to satisfy ourselves, but a balance that can be amenable to the people that are interested in fish, protecting fisheries, and also the regulators that don't really want to move away from their minimum 10 meters. And what we found using the modeling is that if we're at a depth of, I think this is around 7, we can impart some upward velocity to that as it's coming through. The pumps give us that energy to do that, which means that it's moving up and starting to mix. And in a low tide, that will bring us, so if you can imagine when the tide's low, that will bring us right to the underside of the fresh water. And it will become entrained in the fresh water quite easily at that point. Of course, in high tide, well, that's another, 3 or 4 meters. And so it doesn't happen as quickly as that, but it moves us into the zone of water that's mixing at the mouth of the river and starting to move back out of the estuary. So it's a good compromise. And as I said, we have a couple of tools in our back pocket that we may be able to use during periods of extreme concern, like the late summer, in terms of being able to avoid discharging at that time, or discharging only on a strong ebb tide.
thank you.
Okay.
Sure about the depths.
With the new drawings and you're going to a bubble diffuser, that's different technology than the old lagoon has?
Yeah, the old lagoon has a variety of oxygenating mixing technologies. They're often sort of one and the same. Nothing wrong with them. They're appropriate, but fine bubble systems are more energy efficient and more effective at transferring oxygen.
Just another, if we would have taken the bubble technology and put it in the old lagoon, would it have improved it by any means?
Well, it may have lessened the number of times you were non-compliant in one of the many areas where you're non-compliant. How do you like that? All right.
You sound like a politician.
Well, maybe another day. So I think at this point I'll, I'm not going anywhere. If there's other questions, I can come back, but
Well, you can go to the next slide.
I can go to the next slide, sure. Sure, I just want to see. Okay, yeah, so here's the 2 summaries. I think you've seen these already. Right, okay.
Those would be effectively the same numbers that were in the report that you received a couple weeks ago.
I just have one question for our city engineer. 2 questions. One, is this going to affect staff-relating issue in monitoring of the plant, or are we going to be going as status quo? And my second question would be, I noticed through the project components on this for money that there's additional funding required of just over $11 million. And I'm wondering if we have that planned, or?
Yeah, thank you, Councillor Sauvé. The operation of the lagoon is effectively, and I'm looking toward Brian, our utilities manager, is effectively the same as our existing lagoon. So we expect to send an operator out there once a day, pretty much as we do today. That's the good part. The other piece is that this particular design will require a lot more energy. There's compressors, and this microbubbler air system will require a lot more energy. So our BC Hydro bill will be going up. And then your last question was around the additional capital costs that we've estimated. we don't have that identified in our 5-year plan at this point.
Thank you.
So we received a grant for 12.2, was it? 11.2. Or 11.2. And we know that the federal government just introduced more and new funding for infrastructure. I'm just wondering if there's the possibility of more grant funding available to offset that cost. I mean, if we don't have that in our 5-year plan, I think everybody sitting here is hoping that it's not going to delay the finality of this project, beyond that point. But I guess it's a double-loaded question. Do you feel that there may be other grants that could be applied to this, and we need to figure out what we're going to do with 11 million? We've come this far, so we need to finish it.
Thank you. And Mr. Mayor, that's precisely our challenge as a city, is to recognize where we are today. And the answer is yes, I hope we can reapply. With the information that we have, we are more than shovel ready, right? So it's one of those projects that we hope we could reapply for some more funding and be successful.
Sorry. I'm sorry, Councilman.
Thank you. If we are not successful getting more funding for it, with us being kind of maxed out on borrowing, is this the type of project we'd have to go to referendum for to be able to borrow that money? Or is there some kind of provision, this might not be a question for you, but is there some kind of provision for borrowing without a referendum for something like this, because it's not a luxury but a necessity?
Yeah, I'll let Mr. Watson answer that.
Thank you, Guy. Contingent on us getting approval of the liquid waste management plan, that requires the approval of the Minister of Environment, which is a contingent on public input as part of the component of the liquid waste management plan. There is an exemption from the requirements of the community charter for public voter assent. So if it's part of construction of an approved liquid waste management plan, you're not required to use the voter assent provisions in the community charter.
Councillor Sorry.
Did we in any way derailed from the estimate of how much this would cost? Because I know it came down from pressure from the BC government that we have to meet certain guidelines, and that's totally understandable. And I could see with the grants and all that, as to long-term borrowing, we've already done that with the Catalyst Lagoon, and my concern is that was this foreseen that we're going to have a funding requirement of more than 11 at this point right now of $11 million, or is it?
Not at all, Mr. Mayor.
Okay, so this was forecasted all the time.
No. This extra requirement was not known until the most recent time when we started developing the project after moving forward with the preliminary design and moving forward with the desludging, etc. So
what year are you talking about? This year or?
This year. The original grant was 2011, and so it was some 5 years later.
Thank you.
Councillor Washington. Okay. We were asked by the MP Gorjohns to identify additional infrastructure projects, and this was definitely one of the 4 that we presented. We haven't heard anything yet, I don't think, have we?
No, Mr. Mayor, I think that's a good point. Our local MP did ask us and other communities in this area for capital projects that may be eligible, and so we're the first community to reply to him with a short list of projects, including this one. The formality of that process hasn't been initiated by the federal government yet, so it's kind of just that front end work that we're doing right now.
Okay. Yes, go ahead.
Just once again, a little there was a deadline of 2020. Is that deadline just for the waste management plan, or is that to have the project done and up and operating? Just
Yeah, there's a few deadlines. Some of them are overlapping, some of them are not the same. The funding deadline was extended to 2018. The federal government WESR regulation for compliance is 2020. It could be that you're also thinking about, but the funding deadline is the soonest of the two, and obviously the very important in order to receive that funding.
So the 2020 deadline is actually to have that thing up and running?
Correct. Yeah, from a regulatory perspective, the federal regulation, yeah.
And we can see in Mr. Watson's report to council that we have additional funding required of $11.1 million. So it's pretty significant. Councillor Alamani?
So just to wrap my head around the funding question and when this has to all be done. So we're on the hook for $11.1 million. Assuming we have to borrow that money, when would that money have to become available in order for all of the wheels to turn? How long can we wait for the grant or no grant, that kind of thing?
I'll try to answer that by what the next steps are and see if we can put that into perspective over time. So what we're aiming to do now is to complete the Stage 2 liquid waste management plan. So as Tom pointed out, it's nearly done. We will convene the Wastewater Advisory Committee as a group and then finalize some of the details. I should say now that some of these details that we've been working on have been quite challenging around the Ministry of Environment and the regulations around that, but I don't want to get into that too much. But just to say that it has taken us some time and a lot of effort to work our way through that. But so we are working our way through that, and we see the light there. So once that Wastewater Advisory Committee meeting will take place, we'll move it to more of a general open public scenario, and then we'd be looking for City Council's approval, the First Nations approval, and then we would take it to the Ministry for the Minister's approval. So once we get that Stage 2 approved by the regulatory bodies, that would bring us into next year, 2017, and then we would finish up the Stage 3 liquid waste management plan. Now, Tom pointed out it is really just a formality of tightening up some of the cost estimating and the construction scheduling, and get that approved by the same groups of people. Still, I think 2017, because I believe we would want to start full construction. So in the meantime, we'll do some design. So all around saying that toward the summer of 2017. So that gives us a year to.
So construction to start summer 2017.
Okay, at this point, I think, unless there are other questions from council, we need a motion to receive Mr. Watson's report and this entire report. Councillor Soy?
Thank you, Mr. Mayor. That the report from the Major Capital Projects Advisor dated June 13, 2016, providing information on sewer treatment upgrades and liquid waste management plan be received.
There's a seconder?
Second, Mr. Mayor.
All those in favor? Carried. Gentlemen, thank you so much for taking the time. It's a lot of work. Still a lot of work to go in some aspects of this, but we've overcome some significant hurdles in order to get to this point, and I have no doubt we'll overcome the rest of them in order to get it successfully completed. So, thank you, Councillor McClellan.
Yeah, just one question, I guess, to Ken. In your estimation, can we meet this deadline?
Oh, absolutely. I think it's quite compliance regulation, the question that you asked earlier was, I think it revolves around the funding. I suppose we need the additional funding to complete so if there's any delays that might stand in the way, it would be with respect to the additional funding required. And Councillor McCullum had asked a question earlier about the current grant that's in hand and how much has been expended so far. We utilized that money for the desludging project, which is approximately $2 million, and we'll be wrapping up shortly. So say that to round numbers is $2 million. In addition, there's the ongoing engineering, archaeological review, combined sewer overflow monitoring, and the environmental assessment has all been funded through that grant, and that is about $1 million so far. So that would mean we've expended about $3 million of the 11.1 to date.
Thank you.
Okay, thank you very much. Council, a motion to adjourn is in order.
I'll make that motion, Mr. Mayor.
All those in favor? Carried. Thank you very much.